All right, good afternoon, everybody. Thank you very much for attending our webinar, Power on Target, Silicon Carbide Optics for High Energy Laser Applications. My name is Joe Salemi. I'm the OEM Sales Manager for the Optical Components Group here at Zygo.
And my name's Mike Albrecht. I am the Product Line Director for the Optics Group in Middlefield, Connecticut.
So silicon carbide optics are becoming more prevalent in high energy laser designs. So we really wanted to offer up this webinar. We wanted our customers to understand the potential risks early on in the design phase so we could avoid critical pitfalls later. So with that, I'm going to turn off the cameras so it won't be a distraction. And then we'll jump right into the webinar. Thank you all for attending. All right, great. So here is our contact information. Please feel free to reach out to Mike Albrecht or myself directly. If you would please submit your questions via the questions tab in the GoToWebinar toolbar, that'll be great. We're going to try and get to all your questions at the end of the webinar, but if we run out of time, we'll reach out to you. And if you think of any questions after the webinar, please don't hesitate to contact us. So a little bit about Zygo. Many people just think of Zygo as an instrument company. We actually began as an optics manufacturer back in the 70s. Then they didn't like the available metrology that was on the market at the time. So we then made the very first Zygo interferometer. And then, as they say, the rest is history. But over the decades, people have really, when they think Zygo, think instruments and metrology. But really, we've been making the world's best optics for 50 years. And really, one feeds into the other. Excellent optics turns into excellent instruments. And the better the instruments are, the better the optics that you can make. So it's really a feeding cycle between instruments and optics. And, you know, we like to say we've been making the world's best laser grade optics, and really, we're the only trusted source in the United States for laser fusion optics. But you're saying, Joe, this is a silicon carbide webinar. Nuclear optics doesn't apply to me. Well, the point here is that the type of surface figures and surface quality that HEL optics require are actually quite similar to those of the laser fusion optics world. Super smooth finishes, low scatter, excellent surface quality. This isn't new to Zygo. We've been doing this for 4+ decades. This isn't something we would go figure out on the fly during your program. And we like to say that we bring optics, metrology, and engineering into that perfect blend to really assist you in your program. And that also includes, you know, engineering, manufacturing, coding, mounting, as well as assembly. And also here at Zygo, we like to say that we're material agnostic. So what does that mean? Zygo doesn't manufacture any silicon carbide substrates or actually any optical material. You come to Zygo, we will help consult with you on the best material for the application, and that includes silicon carbide. We'll view the specific trade-offs between the various types of silicon carbide objectively, and our only interest is to help you choose the best material to fit your needs. So you can rest easy knowing that you're going to be steered towards the best material for your application. So the goal of this presentation is to really help our customers become well-informed, because we know that this is a key to mitigating program risk, especially early on in the design phase. You know, it's important to be price competitive in this environment, but in these silicon carbide high energy laser programs, going with the lowest bidder early on could actually prove more costly in the long run. So why would you come to Zygo for a silicon carbide optic? You'd come to us for market intelligence, for material expertise, optics manufacturing, engineering consultation. You know, silicon carbide is not your standard buy a piece of glass, grind and polish it. There are many nuances to designing and manufacturing the right silicon carbide optic for your high energy laser application. So the sooner you can get that expert feedback from an experienced optical manufacturer, the lower the risk will be on your program. And using Zygo, who will employ a multifaceted approach, will give you the confidence to navigate design, fabrication, coding, and metrology. So under the section of why choose silicon carbide, so the applications that we would be talking about are high energy laser, space-based telescopes, applications with high acceleration and thermally variable environments. So the key advantages of using a silicon carbide is high specific stiffness, excellent thermal stability, and a resonant frequency advantage over materials like Zygo. Also, they can be formed into complex shapes, and it's also a non-toxic alternative for beryllium. So as it relates to the coefficient of thermal expansion, silicon carbide combines that high specific stiffness with a low CTE in comparison to other materials. HEL optics undergoing acceleration strongly benefit when a material is selected that has a high resonant frequency, and silicon carbide has the highest value out of the non-toxic materials. And high thermal diffusivity is desirable so that heat absorption does not affect that beam path. So as we get into the anatomy of a silicon carbide optic, the mirror face of the silicon carbide optic is made up of the face sheet with a cladding material deposited on top prior to polishing. Bare silicon carbide usually doesn't meet the surface quality or roughness requirement needed for a laser quality surface. And you need a cladding to finish the surface to get to that laser quality. However, there are some exceptions. Now, the cladding should uniformly extend to the edge of the substrate, and during the design phase, it should be considered whether an incidental overcladding on the edge is permissible, and Zygo can work with you on the manufacturability, cost, and lead time. Also, to discuss with your optics supplier the cladding thickness needed for finishing and potential rework. And contact Zygo when you're considering the useful optical area. So in choosing the right substrate material, not all silicon carbide is equal. There are many different flavors. There are different manufacturing methods of making silicon carbide substrates, and each have different parameters in terms of strength, stress, other design considerations. Is the base substrate porous? Does it require silicon infiltration? Different flavors have different cost structures and lead times. And there are several general processes used to create silicon carbide substrates with proprietary technology used by the individual substrate manufacturers. So of primary importance to the end user are really the material properties and whether the manufacturing technique is compatible with the type of optic being procured. A manufacturer's technique could be used to create complex 3D printed structures. But if you have a simple, straightforward design, that supplier might not be the right supplier to use. So if you involve Zygo early in the design phase, you don't need to be an expert here. We already have that covered for you. So in choosing the right cladding, before we actually jump in and talk about the cladding, I want to mention that the pre-clad surface quality is a very important consideration. Substrate flatness concerns and subsurface damage of the pre-clad mirror face can lead to extra optical fabrication down the line. So I want to talk about the two most common claddings we see that's the CVD silicon carbide and versus silicon. This is very common. We have these conversations with customers frequently. So as it relates to silicon cladding, you're going to have a lower surface roughness and better surface quality. The silicon cladding introduces, though, a CTE mismatch. It does tend to be thinner, less than 30 microns, so it conforms to the base substrate very well. However, it doesn't leave for potential rework in the event that you pick up a defect during the manufacturing process, so that is a consideration. With CVD silicon carbide, that can yield good surface figure, but it is limited on roughness and surface quality due to the porosity of the cladding. It does tend to be thicker, greater than 100 microns, so it's a little less conforming to the shape of the base substrate, but may give you some leeway in the event that there is some rework needed. Other things to think about are voids and pits and inclusions in the cladding can also affect the properties. Now, when we talk about mechanical features and mirror geometry, when requesting a quote from Zygo, please be sure to include your drawings for optical and mechanical requirements, but also the solid model up front. That's going to really help us evaluate the manufacturability when we're reviewing the RFQ. So in regards to the face sheet, that face sheet thickness is always something we want to take a look at. Designers want to keep that face sheet as thin as possible in order to keep the mirror as light as possible. But there is that fine line because a very thin face sheet can cause lightweighting ribs from the backside to print through to the optical surface. As it relates to the lightweighting rib structure, the wall thickness of the ribs are limited by certain substrate manufacturers. So if there's a tolerance that is a must-have, that might steer us towards one manufacturer over another. Different suppliers have different parameters for the cross-section thickness, volume, and pocket patterns. So moving on with mechanical features and geometry, other items are, how will the mirror be held? Is it going to be held with threaded holes or inserts? Will additional machining be necessary after the substrate's formed? With dimensional tolerances, you want to try not to overspec non-critical features with working with silicon carbide. Sometimes you can get away with that with other ceramics, but with silicon carbide, we like to stay clear of that if possible. Other items that may need to be considered regarding geometry are center of gravity and mass moment of inertia. When talking about optical requirements, Zygo has the expertise to help you translate your system level requirements into an optical tolerance for your mirror. So as an example, the closer the aperture is to the edge of the optic, the higher the cost. And there are several other considerations such as slope or surface roughness that need to be evaluated based on beam size and laser power. And we can walk with you through this process. Regarding thin film coatings, we have extensive experience specifying thin film coatings for silicon carbide optics. This slide lists some of the basic coating information needed. One key piece of advice is to clearly differentiate the CVD coatings and the thin film coating in your design. Other thin film coating considerations, typically with high energy laser applications, they require low loss coatings, which can be stressful on an optic. And with coefficient of thermal expansion differences between the substrate and thin film coating, the reflected wavefront may be distorted after the coating is applied. So it's vitally important to engage Zygo early in the design process to help mitigate the effects of coating stress. Another key to note is, does your supplier have the capability to measure and compensate for that stress? Post-coat metrology may be problematic if you don't have the metrology equipment at the wavelengths you need. If you don't have that, you may not know if your optic meets the performance criteria until you integrate the optic into the system. And that is the wrong time to find out you have an issue. This is really best mitigated during the design phase to prevent the outcome that's modeled in the image on the right. Compensation techniques we use: finite element analysis, sample surrogate coating tests, polish a bias into the cladding, stress compensation, coating on the backside. Zygo knows every inch of this process, and we can work through these with you at the start of the process, not at the end when a program could be at risk. Additional considerations as it relates to metrology is angle of incidence and center of gravity. Does your polisher know how to polish the part so it comes out that it can function at 45 degrees? We can achieve accuracy to 20 nanometers over a measurement area of 650 millimeters by 650 millimeters. Force of gravity, mounting hardware configuration. Zygo has built their brand on designing and manufacturing metrology. So if you require a custom metrology setup, if there's anyone you could trust with that, it's Zygo. Zygo is that right silicon carbide partner. We'll work with you as a design partner, not just a supplier. And these are important characteristics to look out for when looking for that partner. Extensive knowledge of the material properties and design parameters for the different flavors of silicon carbide. No vested interest in promoting one specific type of material over another. Attention to detail on cladding type and cladding requirements. And we like to say, if you can't measure it, you can't make it. The metrology capabilities are vital, especially if you need a custom metrology setup. The engineering resources to predict and mitigate common issues. Examples include coating stress and print through, the complex metrology needs. We have the bandwidth and firepower to assist your programs. The program management expertise for these type of programs. A lot of these high energy laser programs are DX rated. So going with a low cost supplier means cutting corners in certain areas. Could this be one of those areas? And also that thin film coating expertise. It's all under one roof. If you come to Zygo first and early, we can help plan this whole process for you. So while normally we encourage people to come visit us, we love to host customers and prospective customers here at Zygo. We love to show off our facilities, whether it's in Middlefield, Connecticut, or Richmond, California, or Irvine, California. These are tough times for travel, so we want to invite you to visit our website, take one of our tours. We also have a YouTube channel. Please go and check out our YouTube channel. There's a wide variety of topics there, optics as well as metrology. It's all there. So that's it. I want to thank you all for taking time out of your busy schedules just to listen to a little bit about silicon carbide. This webinar will be posted up on our YouTube channel and our website. We greatly appreciate it. Please, there's our contact information. I'm Joe Salemi. Mike Albrecht is with me. I'm going to open it up for Mike Albrecht if any questions came in during the presentation.
All right, Joe, thank you very much. So there were a couple of questions that came in while we were presenting. So the first one was asking if these slides would be available after the webinar is complete, and they will. This will be posted to Zygo's YouTube channel, so you can easily replay this at your convenience if there's anything you want to go back over. The second question that came in had to do with need for cladding. You know, the question was, is cladding always required? And the answer is no, it's not always required. But in the event that your application requires a laser grade finish or a mirror grade finish, typically it is required, and we can help kind of guide you through that if you want to go with the CVD cladding or silicon cladding and the various trade-offs.
Excellent. All right. Are there any other questions out there, Mike?
Yep, they're just starting to pop in here, so give me 1 second.
Oh yeah, yeah, I see them popping in.
Okay, so a few more questions have come in here. One is, once you have print through, is it game over? Is there a minimum face sheet thickness that's required to avoid print through? So there is not a minimum face sheet thickness. It's really design dependent. It depends on who the silicon carbide manufacturer is, the geometry of the part, the ribs. But in the event that you do end up with print through, it's not game over. There are ways to correct that using small tool polishing, which are fairly routine and well known in the industry. At Zygo, we're able to do that on optics up to 1 meter in diagonal. So another question is, what is the purpose of a thin film coating? So a thin film coating would typically be applied to a mirror to increase reflectivity. In high energy laser applications, there are other considerations such as absorption and scatter as well because of the energy levels that are involved. So those coatings can be very specific, and if you want to inquire about more detail, please reach out to us directly. So one of the last questions here is, does Zygo make silicon carbide substrates or claddings in-house? And the answer is no, we do not. Zygo does not synthesize any raw material, but we've spent several years understanding and classifying the materials that are available in the marketplace, both from a cost and lead time standpoint, as well as their mechanical attributes and optical attributes. We know this very well, and we can help guide you towards the right manufacturer. And one last question we'll get to. There are quite a few here, so we won't be able to get to all of them, but we will get back to you after this webinar has closed. We had a question, does Zygo make assemblies or just component optics? And the answer is yes, we do both. Our group in Irvine, California does EO assembly. They also do design work, and they have experience designing telescopes and beam expanders using silicon carbide optics as well as other materials. And then they have the capability to do rapid prototyping, and we can also do optical assembly in volume. So unfortunately, I think we've just about run out of time, but we appreciate everyone coming on and listening to our webinar. Again, this will be posted on YouTube afterwards, and please take down our contact info and feel free to reach out should you need any additional information.
Excellent. Thank you. Thank you, everybody, for taking time out. Thank you very much.